Hello everyone, my name is Preeti Chandrasekaran and this is my project on image classification using deep learning, which I completed as part of my data science and business intelligence internship at AINE AI. Here you can see in our dataset we have two folders, COVID-19 negative and COVID-19 positive, and in each folder we have many images, and on further inspection we can see that each image has a different size, so we have different heights and widths. So we will bring them to a uniform size during the image pre-processing. Now over to the code. So here you can see the aim and objectives of this project. And we create a list with the different categories. So you'll see that these category names match the folder names in our data set. Here COVID-19 negative, and it matches the names of our folders. Then we store the path to our data set in the directory variable. Then here we do the image pre-processing. We have set the image size to 100, so we'll resize them to 100 by 100, and we iterate through both folders of images in our data set, and we label the negative images as 0 and the COVID positive images as 1. Then using the CV2 module, we convert the images to grayscale to save us time during training. And we also use the resize function to resize our images to 100 by 100 in size. And we also use IMShow to display the image as shown here. In the next block, we have the same logic, except this time we use the try except block for exception handling. And in the real implementation, this would be the preferred approach, because if there is a corrupt image, it will be caught and an appropriate error message will be displayed. We also have a list called data, and this list contains information about each image and its corresponding label. And here is where we populate that data list. Next, we separate the images and the target. So in X, we store the image information, and in Y, we have the target. Now we know that all of this information is in the data list, so we iterate through the data list accordingly and separate the information into the X and Y variables. We convert X and Y to NumPy arrays. Then from the shape of X, we can infer that we have a total of 2,271 images, which are of size 100 by 100. Now, since performing this block of image pre-processing takes time, it's important that we save our work. So we use Pickle to store X and Y. We can see that it was saved as a PKL file. And if we go back to our folder and our directory, you can see that the PKL files are stored, created and stored. And as mentioned before, X stores all the images and Y stores the targets. Now for training. We want to load these X and Y PKL files, so we do this using the pickle load function, and we specify RB, which stands for read binary. Here, when we display Y, we can see that 0 is the label for all the COVID-19 negative images, and 1 is the label for all the COVID-19 positive images. Then we normalize the images by dividing by 255. We also reshape the data for the CNN. Then we start creating our model. So we create a model sequential, since the layers of the model will be arranged sequentially. First, we add a convolutional layer with 64 filters, and each filter is the size 3 by 3, 3,3. And then we use max pooling to convert the 3 by 3 to 2 by 2, and that forms our first layer. Similarly, we add the remaining layers. We use dropout to avoid and reduce overfitting. And then in the output layer, we specify 2, since we have 2 classes. The softmax activation function will convert the input to probabilities. And this is the whole architecture of the CNN. Next, we split the data set into training and testing data. We are taking 10% of the data as testing data and the remaining as training data. Since we're using softmax as the activation function of our output layer, we use sparse categorical cross-entropy as the loss function. We use Atom, which is a very popular optimizer. Now here we specify 15 epochs, which means that it'll go through the data set 15 times. We can see the accuracy slowly increasing with every epoch. It started at around 72%, then it went to 93%, and then ultimately reached around 99%. And then on the testing data, we got an accuracy of around 98%, which is very good. Then we save our model as COVID_model, and you can see that it has been saved over here. Then we define a function to perform the image processing that we did on the data set. So the name of this function is image. Then we load our model using the load model function and store it in this variable called model. Now over here, we specify so we're going to test our model by giving a sample image for prediction. So here first we specify the path of our sample image. Here we have a few sample images, and so we're going to take the first one, sample negative image.jpg. We specify the entire path, and then we pass that through the image function, which we just defined, and it'll perform the image pre-processing. Then that processed image will be passed to our model, and our model will predict whether it is a COVID-19 negative or positive image. And the model predicted that it was a COVID-19 negative image, which is correct. And then similarly, we try again with another sample image, this time a sample positive image, and the model correctly predicted that it belonged to the COVID-19 positive class. And so our model was able to correctly predict for both of these images. Now we deploy our model on the local host using Flask. So here I have PyCharm open with the application running. When we go to the local host page, it will render the index.html code for the front end. And so in the code, we have a form which allows the user to upload an image. Then it runs our COVID model on this image submitted by the user to predict whether it is a COVID positive or negative. And the images uploaded by the user are also stored in this folder called input data. And then here in this predict.py file, we define the functions we use to pre-process the image and implement our COVID and load and use our COVID model. Now here we can see what the page looks like on the local host. And so we see that button where we can choose a file. So we're going to give this new sample image, sample positive image 2. And so I've selected our image and I'm going to click predict. And it has correctly predicted that this image belongs to the COVID-19 positive class. And so we have successfully implemented our model and deployed it on the local host. And it has been able to correctly predict on our sample images and perform with an accuracy of around 98%. Thank you.